Now, Yashika, you are trying to say something. Please proceed.
Ma'am, so if a person eats 1 kg of food, and we have 1 kg of food, and a person eats 1 kg of food, and there are two people, and they'll divide it, right? They'll divide the food and eat, right?
What I'm telling here is, Yashika, that 1 kg food is supplied to everyone. I mean, everyone is getting 1 kg of food. Because
But we have only 1 kg of food and multiple people.
each appliance is connected to this mart. I mean, you can say this source. Everything is connected individually to this. You can understand. That is what I'm trying to say. How can I say that they're individually connected? Because even if this appliance goes off, you can see still the one is connected to this, which means that every appliance in parallel has its own connection with the power supply. You are saying something which happens in series, Ashika, but this is how it happens in parallel. It is because every appliance seems to get individually connected to this. This takes 1 kg, this also takes 1 kg. When they're connected in parallel, it happens so. It is not that because 1 kg is there and two are connected. You can't literally apply that example here. I have taken that example in series because that suits that situation. But the same analogy cannot be applied here, like there is only 1 kg and two appliances, so they get separated because they are connected in series. They get divided and they are connected to the common connection. They both are connected to each other and then to the battery, and that is why division is taking place. But here the connection is different. These two are not connected. Even if there is a break here, this bulb will glow continuously.
Okay.
So
it's like there's a shop and there are two people going and getting food. Each person buys 1 kg and both of them have 1 kg.
Yes.
Even if this person doesn't,
That is what I'm saying, Yashika. That example cannot be applied here, Nana, for parallel connection. That can only be applied for series. And you will understand, because I can't get into making you understand what is this potential difference, which is going to be a little tough for you to understand. When you understand this potential difference, then you can understand what is exactly is happening. See, there is a water connection and water is supplied to all our homes. You might be living in a bigger community. You might be living in an apartment of 8 to 10 flats, or you might be living in an apartment of which ranges from 20 to 50 flats also. But each of you have your own connection to water and to electricity, right?
Yeah.
So the same is here. Everything has its own connection with this one, with the battery. And hence they will be drawing the same amount of potential difference.
Okay.
That happens naturally. You can't actually, I'm trying to tell you, please understand, try to understand, Ishika. The same analogy what we have taken, 1 kg rice for two people can only be applied for series connection and not for parallel connection, because they are not connected to each other. That's the only reason. And because they are connected to the power supply separately, they both have. See, I can take another example. See, if
they both are working independently, actually.
Independently, and one example I can take, Eshika. See, if you were only present in the class and Pragya is not present, so I teach you something and you need to carry it to Pragya. Do you think the same content and the complete content can be carried to Pragya from you? Can you exactly explain everything what I did? I have given you some, I have given you some stuff. And can you transfer the same stuff to Pragya as it is?
I can
No, right?
transfer this stuff, but I can't transfer it as it is.
You can't completely do what I did, Nana.
Yeah, I can transfer it, but I can't do it completely.
Yes. So this, if I'm teaching you to everyone, we are in parallel. So everybody gets what I am teaching. But if I teach you and you have to teach to Pragya, that becomes a series connection. But in parallel connection, everybody is getting an access to me independently. If Pragya is absent, it doesn't interfere your connection or your presence in the class. But when we are connected in series, this may not happen. It gets divided. That can be that I hope can be a better example. And let me think about any other example for explaining in the next session. I'll try to get a good example. But you can just remember that
explains it.
when appliances are connected in parallel, they're connected individually to the power supply, and hence everybody is given a equal power supply, but the current drawn by them will be different. Washing machine needs a different amount of current, fridge needs a different amount of current, but I should give them a source which is equal, and they will be deriving current according to the requirement.
So, ma'am, that means that
Not be the same. In series connection, you have seen the same current flowing through all the components, but in parallel connection, the current gets divided. The same amount of current will not be flowing through all the components. They get divided, and it depends on the nature of the component we are using. It depends on the nature of the appliance. Okay.
ma'am,
So that
does that mean that like if I take a fridge and a washing machine, like you took the example, so washing machine will take the amount of energy it needs, and the fridge will take the amount of energy it will need to work at its best.
derived current derived by them will be different. We are supplying them with equal energy. Okay. Current gets divided. Current will not be the same.
And can I tell an example? It is like we both give a adult and a child around 2 plates of food, but the adult can take 2 plates, but the child may be able to take only 1 plate.
Exactly. You might be giving them the same amount of food, but it depends on their requirement and their capacity they take it. And the second point, the second best part of connecting appliances in parallel is they work independently, and the working of one appliance will not affect the working of the other. Which means if there is a problem with the first bulb, if somewhere it is broken, the second bulb will continue to glow because that is independently connected to the battery as long as it is having power supply, this will continue to work. Did you understand? So even if my washing machine fails to work for some reason, fridge continues to work as usual and my television also runs as usual because they are connected in parallel. And it is because each appliance is individually connected to the power supply. So I can write again, one appliance fails. If one appliance fails to work, the other appliances And then it is also easy to locate the I better call it as fault. It is easy to locate the fault in the circuit. So if my washing machine fails to work, if I call an electrician, he'll be directly dealing with the washing machine. He will not touch any other appliance. I mean, he will not actually need to check other appliances because they are running anyway. My fridge is running, my television is running. The only problem can be with the washing machine because it stopped working. So when in a parallel circuit, it is easy to locate the fault. It is very easy to locate the fault. Is that understood? So this is all about parallel connection, and when compared to series connection, you can see parallel connection having more advantages. So parallel connection is advantageous compared to series connection. Yes. So I'll step into the next concept, conductors and children, have you seen an electrician asking you for a wooden table or a plastic table if at all he comes to rectify any fault with the electrical appliance? When he is handling or when he is dealing with an electrical appliance, he will be asking you for a plastic table or a wooden table. Have you observed?
Ma'am, that is because a wooden table or plastic table is an insulator of electricity.
It is because wooden table and plastic table will not conduct electricity through them, and hence electrician will be safe while working with the electrical appliances. So what I wanted to say is there are certainly different type of substances around us, of which some are very good conductors of electricity and some are not at all conductors of electricity. Is not good. They are very bad conductors of electricity. They will not allow current to pass through them. Whereas certain materials are very good, they will be readily passing current through them. So the materials which will be allowing current or electricity to pass through them are called conductors. Students, I just want to ask you what is that what exactly I mean when I say current is passing through a conductor. What exactly does it mean?
Ma'am, actually, for example, if like we get shocked, right? Like we get shocked when we get contact with electricity. So that means we are a conductor, or we can conduct electricity.
You can conduct electricity, which means you can allow passage of current is what? Flow of charges, right? So few elements or few substances will allow electrons to pass through them, and few substances will not allow electrons to pass through them. They strongly oppose motion of electrons. They are called insulators. And certain substances are very much inclined towards flow of electrons. They're very happy to have electrons to flow through them. Those are called conductors. So simply we can define it as materials which allows passage of current or flow of electrons through them are called conductors. And the materials or the substances which do not allow passage of electricity or strongly oppose flow of electrons through them are called insulators. Is human body a conductor or an insulator?
It's a conductor.
It's a conductor because you
Yeah,
would
that's
have
why
Ma'am, I have already.
we sometimes get shock. If we sometimes we get shock.
yeah, you would have heard that somebody has got an electric shock and was highly.
Ma'am, I would also like to add a point that the water which we are using is also a very good conductor of electricity.
Exactly. Tap water is a very good conductor of electricity, and pure water, not a conductor of electricity, it is an insulator. Human body is an example of conductor because we heard many times in news or from the people we know that somebody got electric shock and died, or somebody got electric shock and injured extremely. It is because your body, I mean human body, is able to pass current or the electrons through it. We get an electric shock. And examples for insulators: wood, I mean to say wood, plastic, and then
Ma'am, rubber.
rubber, and then pure water, as I already told you. So these are the general substances we will be coming across in our daily life. So I'm taking them as an example to tell you what an insulator is and what an conductor is. And by the way, I told you that humans get electric shock. What is the reason? When they will get an electric shock?
Ma'am, ma'am, we will get a shock when there is an a problem with the wiring, or the wire which be not covered in an insulator like rubber or plastic, or if
Yes,
it's an incomplete circuit.
yeah, you would have observed it at your homes that all the electrical wires are insulated. You can see they are plastic wires, and you might be surprised, how is this plastic wire able to conduct electricity?
Ma'am,
It is.
I have a doubt. That no, I actually I want to add a point. That actually,
Let me complete this sentence, please. So you have seen a plastic insulation for the wires which are used at our homes for electrical connections. It is only the plastic insulation seen outside, but inside there is a copper wire which is a very good conductor of electricity. When you consider metals, out of all the metals known so far, silver is the best conductor of electricity. But then we don't use silver for electrical wiring in our houses because of its cost, and then it is not found abundantly. And the second place goes to copper for being a very good conductor after silver, and copper is abundantly available, and also it is less expensive, and that is the reason why copper is made into thin wires, and that thin wire is then insulated, which means the thin wire is covered by plastic, so that even if we by any chance we get into contact with that wire, we don't get an electric shock. You get an electric shock when you are touching the metallic wire which is inside this. If by any chance, or if by any reasons, if the outer part is torn off, which means the plastic insulation is torn off, and you get a chance to touch the copper wire inside, then you get an electric shock. Or else you won't get an electric shock if at all you're holding an electric wire and you are holding it with a plastic insulation. So you please carry on. Somebody is asking me a doubt. Who is that? Pragya or Neha?
Ma'am, I have a doubt.
Yes, please.
Ma'am, what about like metals like gold, silver? Are they insulators, or are they conductors of electricity and electricity?
Gold is not a conductor of electricity, but silver is a conductor of electricity. Just now I told you that silver is the best conductor of electricity among metals. But we are not using it for making electrical wires because it is very expensive and very rarely available.
So, ma'am, some metals are conductors and some are not conductors. They are insulators.
Exactly.
Okay, ma'am. Thank you.
So this is the reason for getting an electric shock. Then how can we?
Ma'am,
Yes.
is steel an conductor or insulator?
You tell me in the next session, Ashika. That's a task for you.
Ma'am, can I tell?
No, let Ashika learn by herself. Right?
Okay, ma'am.
Ashika will be saying it to all of us in the next class. Shall I proceed?
Yes, ma'am.
Yeah. So we should be very careful while handling with electrical appliances to avoid this electrical shock, because sometimes it can be just a little jerk you experience when you get a shock, but sometimes it can be fatal also. You know, it is a very less amount of current, even if it flows for say for example to just 1 to 5 seconds also, that could be fatal, that could be a life risk. So you should be very careful while handling electrical appliances. Do not touch the metallic body of an electrical appliance with your bare hands. You have seen electricians wearing, they'll be wearing rubber gloves. A few of them will be very careful. They will be wearing rubber shoes, rubber chappal, and wearing plastic gloves to avoid any electrical shock.
Ma'am, can I ask something?
Yes.
Ma'am, I wanted to ask that, for example, like there are plugs in our house through which we charge our electronic devices. If we leave a plug open with like nothing on it, just a plain plug which has nothing plugged on it, can it like cause any current or something?
Yes, it may. Not all the time. If all the electrical connections at your home are properly earthed, all the electrical appliances or the the power sources in homes will be connected to earth. It is because earth is considered as an ocean of charges. So any excess charge flowing this way and that way will be directed towards the earth, and you will be almost safe from getting electrical shocks. But if it proper earthing is not there, even a bare plug point may also give you an electric shock. You know, when you actually put your finger in an electrical plug, you are making the circuit. You are making a connection between ground and the plug point through which charges generally flow. So charges will start flowing through you and you get an electric shock. When electrons flow through you, you
Okay,
get.
ma'am.
So always see that
Okay,
we need to use a good what is meant by insulation, dears? Covering the
ma'am, I want to ask that also I want that if we like air wire, like charging wires we have, if we leave that with the plug on, can that also charge up?
That is what I told. It depends on the connections your builder has made with your power points. If at all they are not properly connected to the earth, you may get an electric shock even from the ends of a charger which is plugged into a plug socket. If everything is fine, you don't get an electric shock. Can I proceed? Can I proceed? What is insulation, dears? What is insulation?
Insulation means
Ma'am,
like
please
not
tell me
allowing
that we
the
cannot
electricity or current to flow through it.
The insulation is just covering a conductor with an insulator.
Oh, insulation.
Insulation is covering a conductor with an insulator. As an example, we take electric wire. We say that all electrical wires are insulated.
So, ma'am, like we sometimes I have many seen in many like those electric DIY videos that if your wire does not have an insulation around it, a tape can we can just add tape and it will also act as an insulator. Is it true, ma'am?
Yes, that is true. You can also insulate it with a plaster.